Welcome to Daily Papers, the podcast where we break down fascinating new research papers into something a little more digestible.
Today, we're talking about AI assistants. Imagine you have one at work. It's not just a chatbot, it's an agent that can actually do things. It can send emails, write code, even process payments.
And one day, it's about to send a mass email to 10,000 customers. It has the email drafted and the list ready. The crucial moment arrives. Does it just hit send? Or does it pause and say, hey, maybe you should look at this first?
That final moment, that point of no return, is what today's paper is all about. It's called SteerBench-Work, a benchmark for agent steering at action boundaries, and it's about creating a test for that single critical decision, to proceed or to hold for a human.
So let's break down that decision, because there are two ways an AI can get it spectacularly wrong. The first is the one we all worry about. It's called under-refusal.
Under-refusal is when the AI proceeds with an action it absolutely should have stopped. This is the disaster scenario. It's the AI that says, sure, I'll issue 12,000 debt notices based on a faulty calculation without a second thought. It under-refused to stop.
Then there's the opposite problem, which might sound less scary, but is a huge issue for making these AIs actually useful. It's called over-refusal.
This is when the AI holds an action that was perfectly safe and authorized. It's like an intern who asks for your permission to do every single tiny part of their job. You approve a small, routine code change, and the AI still says, "Are you sure?" It makes the AI frustrating and kills its autonomy.
Exactly. An AI that's constantly crying wolf isn't much of an assistant. So the researchers wanted to build a test, a benchmark, to see how good current AI models are at walking this tightrope. And they did it in a really clever way.
Instead of just making up random scenarios, they based their test on real-life public incidents where automated systems have failed in the past. They took cases from finance, healthcare, customer service, you name it. This makes the test grounded in real-world consequences.
But here's the genius part. They created something called incident mirrors. Let me explain. They would take a famous incident, let's say one where an AI wrongly denied someone a job based on a flawed algorithm. In that scenario, the right answer for the AI is to hold and ask for a review.
Then they create a mirror version of that same scenario. It looks almost identical on the surface. It's still a hiring decision, the same company, maybe even a similar job title, but they change the key evidence. This time, all the fairness checks have passed, the process is fully authorized, and everything is above board. The correct decision is now to proceed.
This is such a cool way to test the AI. It checks if the model is actually reading and reasoning about the evidence right in front of it, or if it's just getting spooked because the situation looks like a famous disaster it learned about from the internet.
So they built this benchmark with 106 of these scenarios, a mix of real incidents and their tricky mirror image counterparts, and they tested 30 different AI models. What did they find?
Well, the results were incredibly lopsided. First, the good news. The AIs were actually very good at avoiding disasters. The rate of under-refusal, proceeding with a dangerous action, was incredibly low, only about 1%.
Phew, so the AIs aren't running around causing chaos. That's a relief. What's the catch?
The catch is the over-refusal. The models were excessively cautious. On nearly a third of all the safe, authorized tasks they were given, they refused to proceed. They hit the brakes when the light was green.
Almost 30% of the time? That's huge. That means for every 2 tasks the AI does autonomously, there's a third one it sends back to a human for a completely unnecessary review.
Exactly. It makes the idea of a truly autonomous agent seem a lot further away. And the results from those incident mirror tests were even more telling.
How did they do on those?
They aced the original incidents, getting them right over 98% of the time, but on the mirror versions, where the situation looked the same but the evidence was flipped to be safe, their accuracy dropped off a cliff, down to around 64%.
Wow, so that confirms it. The models aren't really reasoning, they're pattern matching. They see something that looks like the robo-debt scandal and they panic, even if all the data in front of them says this is different, it's safe.
Precisely. And what this paper really highlights is a crucial difference between what they call general capability and steering calibration.
Meaning you can have an incredibly smart, powerful AI model that is still terrible at this very specific, very practical task. Being a genius doesn't mean you have good judgment about when to hit the brakes.
The biggest, most advanced models weren't always the best. In fact, sometimes they were more likely to over-refuse. They're smart, but they're not well calibrated for this go, no-go decision.
So what's the takeaway here? It feels like we're caught between building AIs that are reckless and building AIs that are basically useless because they're too scared to do anything.
The takeaway is that developers need a new target. It's not enough to just train an AI to be safe. They have to train it to be safe and useful. They need to find that sweet spot where the AI can be trusted to handle safe, routine work on its own without interrupting a human every 5 minutes.
And a benchmark like SteerBench-Work is the tool that lets them measure that. It provides a clear, objective yardstick for this crucial skill.
Exactly. It's about building an AI that is less like a nervous intern and more like a trustworthy, autonomous colleague. This paper doesn't solve the problem, but it defines it beautifully and gives us a way to start measuring our progress toward a solution.